So before I give you the next formulas, I kind of wanted to show you why we need them. So if we think about this, we're so used to the distributive property. It seems like this should be true. That if we had cosine of two things added together, we could do their individual cosines. As it turns out, if I said like cosine of 30 degrees plus 60 degrees, okay, let's see if that would work if I distributed. What is the cosine of, or what's 30 plus 60? Let's start there. What's the cosine of 90? Cosine square root of the bottom over 2, so that would be 0. Okay, what's the cosine of 30? Square root of the bottom over 2. Cosine of 60? Radical 1 is a 1 over 2. So, are they the same? No. For trig functions, if you have angles with multiple terms, you can't just distribute, but we do have formulas that will break them apart. So, on our sum and difference tab on your flip chart, we will have a total of 6 formulas here, just so you can kind of gauge it. Today we'll do cosine only. Make sure you write these down though correctly. The signs get a little. Alright, so we're going to use that to find some things. If I say exact value, that means with radicals. So even if I just type cosine of 75 degrees in my calculator, it's going to give me a decimal, not the answer I'm looking for. But what we can recognize is that 75 is the same thing as 45 plus 30. Okay, I'm trying to pick angles that I have on my unit circle. Now, probably not the only option. You could also do like subtract angles to get it. But we're just trying to come up with one option. Either two things we can add or subtract to get this. So from our formula sheet, cosine of A plus B breaks into cosine of the first, cosine of the second, minus sine of the first one, sine of the second one. Alright, so cosine of 45 degrees on our hand trick. Cosine is the square root of the bottom over 2. So cosine of 45 is radical 2 over 2. Times the cosine of 30, square root of the bottom over 2, radical 3 over 2. Minus sine is the square root of the top over 2, so sine of 45 is radical 2 over 2. Sine of 30, square root of the top over 2 is 1/2. So if we multiply radical 2 times radical 3 is radical 6. 2 times 2 is 4. And so radical 2 times 1 is radical 2 over 4. You can leave it like that, or since they do have a common denominator, you are welcome to write them as a single fraction. I don't care which of these answers, you just need one of them. Is that okay? So let's say I asked for the cosine of 17 pi over 12. Okay, this is usually harder if it's written in radians, because when you add and subtract fractions, you have to get a common denominator anyway. So my recommendation, if I give you something in radians, go ahead and just convert it into degrees. Remember, we do that by multiplying by 180 over pi. So 17 over 12 times 180 So now, I need two angles from my unit circle that would add or subtract to 255. I'm not just going to be able to use 30, 45, and 60. It's not going to be enough. So if you need to, pull out an old unit circle or find one in your book. But we're thinking about all of those angles. Are there any that would add or subtract to give us 255? You can, but you would have to do 270 minus 15 to get 255. And 15 isn't one that we have on our circle. But right idea. So, if we do 300 minus 45. Both of those are on my unit circle. And 300 minus 45 is 225, or 255. Those aren't the only combinations. You could have done like 120 plus 135. You're going to get the same thing. Now when we do this, the minus right here just tells me I'm using the difference formula, the subtraction formula. So if you're looking at your formula sheet, cosine of A minus B is cosine of the first, cosine of the second, plus sine of the first, sine of the second. Alright, so now we have to think about this a little bit. 300, that's quadrant 4. Reference angle, 360 minus 300 is 60. In quadrant 4, is cosine positive or negative? Positive, and the cosine of 60 is? Cosine of 45, that's just in the first quadrant, so just a hand trick, radical 2 over 2. Sine of 300. In quadrant 4, sine is negative, sine of 60, radical 3 over 2. And sine of 45 is radical 2 over 2. So now if we multiply, 1 times radical 2 is radical 2. 2 times 2 is 4. Plus a negative would be minus radical 6 over 4. You can leave it like that, or if you prefer to write them together, that's fine as well. So it's pulling in a lot of the old stuff. Knowing those angles on the unit circle, you have to be able to think about quadrants and reference angles to know if your values are positive or negative.
Are we just leaving all of the radicals, or will we be working on it?
Yeah. No, just if you happen to end up with something weird like a square root of 12, break it down if you can into 2 radical 3, but yeah, your final answer will have a radical in it on most of these. I can do this one. The cosine of 173 degrees, cosine of 83 degrees, plus sine 173 degrees, sine of 83 degrees. So this one, it kind of looks like I gave you the right-hand side of the formula. You have cosine, cosine, plus sine, sine. And I'm looking at my formulas. Cosine, cosine, plus sine, sine. That turns into cosine of A minus B. So this is the cosine 173 minus 83 is 90. And what is the cosine of 90? How are we doing with these so far? We could have proofs involved in these, so let's take a look at one of those. Alright, so we know with our proofs, we always try to box in a side. Which side would you want to box in first? And so now we can use the cosine of A plus B formula for the left-hand side. So the formula says cosine of the first, cosine of the second, minus sine of the first, sine of the second. Cosine x, there's not much I can do with, but cosine of 2 pi I should be able to evaluate. 2 pi is the same thing as 0. What is the cosine of 0? Two over 2, which is 1, minus sine of x times the sine of 2 pi is the same as the sine of 0, which is 0. So I just get cosine x minus 0, or cosine x. What I like to do is, I have 2 more samples. I think I can get through them, and then you guys can just have work time. I want to write it as a single function. What does this remind you of, though? Which formula is it? So I know this is cosine of A plus B. So if I'm just simplifying this, A is my first angle, which is 3x. B is my second angle, which is 2x. So 2x plus 3x is 5x. And that's all we can do there. Just getting you to recognize that that was an identity. We could simplify it. Last problem of the day. asking you to verify, I'm asking you to prove it. Which side would you box in? I don't have a formula to break apart secant of a minus b, but I could recognize secant is just 1 over cosine of a minus b. So now I can do the cosine formula. Cosine of the first, cosine of the second. Because it's a subtraction, we have to add sine of the first, sine of the second. If you think about on your unit circle, 3 pi over 2 is right here. That's the point. 0, negative 1. Cosine is the x, so cosine of 3 pi over 2 is 0 times cosine of x. Sine is your y, sine of 3 pi over 2 is negative 1. Zero times cosine is 0, and sine x. So I have 1 over negative sine x, and what is the reciprocal of sine? So that is negative cosecant x.